today we're talking about part 2. So we talked about part 1 of the geometric sequence and series. So part 1 was this one right here, where we already found it. So part 1, we found the rule. Okay, so we found the rule for the finite sum. Okay, this is a sequence. And the rule is S sub n, the sum of the first n terms. Okay. And I'm going to use ellipses here to represent continues. The sum of the first n terms that you see here. Okay. And this is your rule. Okay, so we found that. And we said when we derived it in one, I'm not going to derive it here, is that it has a rule, a times r to the n over 1 minus r, where r equals the common ratio. And r is not equal to 1. Okay? Now, we looked at the example that we have. I'm just going to turn the light here on. Okay. So we looked at the example. The example was r is equal to 4. So that's the example we had here. 3264 plus 128. And we said r in this case was 2. We multiply by 2, it doubles. Now, for finite, it works. For infinite, the infinite geometric series for part 1, if we were to add it up, and I'm gonna erase it here, sorry. And I'm gonna just put ellipses here. We added up continue. The sum is just gonna continue. There is not gonna be any number. So what we say is this diverges. Okay. So now let's look at a series where it actually converges. Okay. So I'm gonna look at this convergence here. And we're gonna look at a geometric convergence. So 10, 5. So let's look at a sequence first. 5/4, 5/8, dot, dot, dot. And it continues on forever. So this one, r is equal to 1/2. Okay. So what I'm going to do is I'm going to place it into the finite sum. 10, 1 minus 1/2 to the n, 1 minus 1/2. Okay. This is something new right here now. I'm going to introduce, called the limit, or if you might have seen it before, the limit of S of n as n approaches infinity, okay, is equal to, so I'm going to write this here so you can see here. Now this number is actually 1 over 2 to the n. What happens to that fraction as n gets bigger? Well, this gets smaller and closer to 0. So we have 10 times 1 over 1/2 equals to 20. So this geometric sequence, if you were to add it up, 5 plus 5/2 plus 5/4 plus 5/8 plus dot, 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 it becomes a geometric series. Geometric series. And more importantly, it's an infinite geometric series. Okay. If you were to add this up, it adds up to 20. Okay. So the sum of the infinite geometric series adds up to 20 for that example right there. Sequence, you listed the terms. Series, you add the terms. Now let's look at the finite sum that we figured out from part 1. Okay. Then I'm going to do the same thing on this one. I'm going to take the limit of S sub n as n approaches infinity equals the limit as n approaches infinity. I'm going to write this here for completeness. 1 minus r to the n, 1 minus r. Now, if r is between, the absolute value of r is less than 1, that means -1 less than r less than 1. So if it's a fraction, what happens is this approaches 0, just like the example, and what we end up with is it converges to the number a over 1 minus r. So infinite geometric series converges to a over 1 minus r. And that's your infinite geometric infinite geometric series.